Hello Internet. Today we're finally going to socket replacement. Not exactly the correct order of words, but you get the idea. We have a socket that has damaged pins and we need to replace it, and so today I'm going to show you how I do it and how I succeed 100% of the time. So first order of business, what we need to do is we need to take this thing apart, obviously. There are different ways of doing these things. Depends on the board, how it's designed, and other things. But the most important part is we need to remove absolutely everything off of the board, every single cooler, every single panel, every single thing, and things on some of the motherboards near the NVMe, like the turning retainer clips or whatever you want to call them. If you see them plastic, they need to be removed. In this instance here, I believe they are some sort of a push button activated. I'm not exactly sure what's going on in here, but I'm going to be removing it all anyway. And all the heat sinks are going to be gone. And it looks like somebody had already tried to mess around here, because these screws and these screws don't look the same. But who cares? I'm going to go ahead and remove all this and show you what I've got left. Right, so the board is completely stripped as much as I could, and the probably the biggest flaw in the way that these things are approached by other repair shops is to request a customer to strip the board prior to shipping it to them. What happens then is the customer, who doesn't do this every day like the repair shop would, ends up damaging the board, not even realizing it. And so by the time it is fully disassembled and shipped it over to you for as simple of a job as a socket replacement, the damage is already on the board. User isn't aware of it, or the customer, you aren't aware of it, and so you replaced the socket, you did a fine job, send it back, and then it doesn't work. So that's never going to happen with me, because I do not let my customers to disassemble the board, and I disassemble it myself, so that way I can guarantee that it was properly assembled. And also, another thing that some of the shops may not know that they might need, it just depends on the BGA or the preheating station that you have, you might need a bracket for each type of mount. So what that bracket will do is essentially it's just a used bracket from one of the it doesn't have to be the original one. It could be the aftermarket one that comes with the cooler, but I ended up throwing away the cooler, just keeping the bracket. Just bought the cheapest bracket possible, and then I'm going to mount that bracket back on the back side of the motherboard. And the reason why I do that is because this bracket will serve as the straightener support, sort of, for the lack of a better word. Basically, it will keep this board from warping as it heats up. That's basically all that is, because when heat starts to apply to the board likes to go all over the place, and I do not want that. I want my board as flat as possible, and I'm taking every measure to accomplish that. One such measure is the bracket, such as this one, and the other one is obviously the preheater itself. You can obviously tell this one hasn't been used for quite a bit. It's all covered in dust. Let's see here. That's quite a bit of dust, actually. Holy cow, that's a lot. Look at all that schmoo. Jeez, I need to vacuum that out. And hopefully that's it. Now, the issue with this particular preheater is that it may not necessarily be big enough, especially for the premium sized board such as this. So allow me to make some adjustments, though we might get lucky. I'm not 100% sure that we will, but worth a try anyway. Undo these screws. There we go. So that's gonna go here like so, and then, oh look, it is just right. Now here's an issue. Even with a preheater that is seemingly large enough, we're still having a problem of keeping the board where we want it, and it's kind of right where I want it, if you ask me. But the thing is, the board will flex and sag, and it's going to start to play around. So ideally, what I would want to see, instead of what we have going on in here, is to use a little bit of a different approach, and to be more specific, is to use a much larger preheating platform, such as this puppy right here. That's what it looks like at the front. There we go. That's what it is. That's what the platform is called. 430. I think it's 40 by 30. 400 by 300 millimeters, or 40 by 30 centimeters. Well, we can have a look at it. Let's measure that. See if that's true. Yep, that's 40 and 30. Now, this thing originally was overpowered, so I ended up stripping a lot of the aluminum mass using a milling machine. I added lower power heating rods, but at the same time, there's more heating rods now, but in combination, they do not pull anywhere near as much power, yet I get what I need. So it heats up faster because of the lower mass of the aluminum, and it does not trip my circuit breaker all the time, so I can safely use this. I think it pulls about 15 to 18 amps, so I can definitely use this with my setup with a little bit of room to spare for the heat then that I will be needing to bring from the top in order to finish off with the process. Now let's see how this board looks, and we can see now that this board is going to be heated way more evenly because of the size of the preheater. And so all I gotta do now is, and by the way, I want to be honest, I have not used this preheater for this type of work, not yet anyway, but today I'm going to try. And so first problem that I'm running into is I think that these screws here are a little bit too long, so I'm gonna replace them with the shorter ones so that I can bring the motherboard closer to the bottom of the heating platform. And as a matter of fact, I might as well even ditch this whole frame bottom here to begin with, because I will be using standoff pins to keep everything flat, and since we're not using this old preheating station, we do not really need this bracket because we're going to be using standoff pins to keep the board flat. So let me go ahead and prep the board, show you what I got. Alright, so the board is now with the pins in as many places as I possibly could. So it's still going to want to play a little bit, so I will strategically place just random weights here and there, depending on where it's going to want to move. So I'm guessing it's probably going to be a couple of places, you know, here and there, maybe, whatnot. We'll see. The main issue that I'm having right now is I need to protect all of these electrolytic capacitors. So everything that usually gets damaged is covered, and so the new socket is going to go over here, so that way I keep it nice and warm. And we're going to need to bring in a temperature sensor of some sort, because this particular one does not have one. So I'm going to use the multimeter and a dedicated, or rather a sensor or temp sensor, temperature probe that I have laying around, and I'm just going to use a multimeter to monitor the temperature. And we're going to attach, not so much attach, but to kind of position the probe next to the socket, and we're going to make sure that it does not move a whole lot. So something like this, and then some kind of a piece of weight that will serve a double purpose of not only holding it down, but also it will also provide a little bit of weight on the motherboard so that it does not move around too much. And so let's start heating this thing up, see how it goes. One last trick after replacing the weights is to help the board to warm up quicker, as well as distribute its heat. I will be using this heat resistant cloth, so I'm just going to go ahead and actually I'm going to saturate the socket with flux, maybe even put some in the middle. For removal purposes it's okay, but for installation I will not put anything in the middle, because I do not want to ultrasonic the entire board. I do not have an ultrasonic big enough. So I'm just going to cover that and just going to let it sit and watch our temperature gauge until we get to about 150. It'll probably be a good number. Alright, so we are at 150. So we're gonna remove the blanket and we're gonna start cooking this thing until it becomes loose. I do apologize for all that squeaky noises that you're hearing. And so I'm kind of moving around. I'm not focusing on it in any particular area. So, and what I'm looking for the socket to become loose. And I need to note the temperatures at which it becomes loose. And that's going to be my baseline to where I should consider replacement of the socket to be complete. Because it's using lead-free solder, it's usually around 240, 250 somewhere. It depends. Trying to nudge it once in a while. And then I would probably overshoot that temperature just by a little bit to be on the safe side. But until we get to that point, it's a guessing game. You can see that the temperature is kind of jumping all over the place a little bit. That's normal. Probably would have been better if we heated this thing up a little bit more, maybe like to 180. That would definitely be quicker, but that's okay. So 230, I think we're starting to kind of get there. 230, 240, I think it's gonna give way. I don't know, it's been a while since I've done this. I'm guessing about 245, 250 is where this thing's gonna come off. Alright, I think it's about to come out. Gonna lift this out of the way. There we go. And we want to work quick. The faster we do it, the better, because we do not want this area to cool down. Also, while we're doing this, we probably want to disconnect the entire unit from the ground, so that way we do not accidentally shoot any kind of voltages into any of these pads, potentially killing some kind of a circuit along the way. Alright, so here we have that. Let's clean that up. I like using black quartz for removal of the components or sockets or cores because it's very easily cleaned afterwards, and I've had great success using his flux. I always do. Alright, let's go and wipe this off with a cotton ball. Looks like in this case we got plenty of room to make sure that we don't get any fluff accidentally trapped under. Okay, now let's go and apply some flux. That's a different flux. This flux is specifically for lead-free stuff, or lead-free solder rather. Works really well. Alright, here goes the socket. Should already be hot and toasty by now. And let's fight with that socket for a little bit, trying to get it positioned properly. And that looks reasonably well, I think. Yeah, I think that looks. Could be a little bit of room for error, but it should line itself up as it gets hot. So, okay, I think that should be it. I'm going to go ahead, reconnect the preheater back to the ground, and we're going to make it a little bit easier on ourselves and preheat the board just a little bit more, maybe 180 or so, because right now it's at 140, a little bit too low. So kind of explains why I struggled with removing the socket in the first place, but we got it off, so who cares. Let's warm up the board to ease our process. And if we noted, the temperatures for the removal were about 250. So those are the temperatures that we're looking for, though we need to overshoot that a little bit, maybe by another 10 degrees or so, just to make sure that the balls are really soldered. Alright, we are 180 and supposedly still climbing, so let's quickly remove this and bring in the hot stuff. See if we can bring this thing up to 250 as quick as possible. We do not want to be focusing in one place, but rather move around. And as I was removing it, I noticed that this area here on the left was running a little bit colder than the area on the right, because I do have a heating element in the middle and on the sides, but not in between. So that kind of explains the way it behaves, and that's normal. We're just gonna have to compensate with applying a little bit more heat toward this end rather than here. 234, we're getting there. I want to see like 260, and I'll be happy with a 260. Almost there. I suppose I can kind of nudge that thing and see if it actually soldered. I think it's soldered. It tends to bounce a little bit. That's exactly what I want to see. I know you can't see it, so I think we're done here. Hopefully everything went well. And on a side note, the way I know whether or not you should be unplugging your unit from the mains or from the ground is for you to know whether or not that's going to happen. All you have to do is to remove your soldering iron, watch your display for the soldering iron temperatures, and then just touch the ground. And if there's something going on in there, then you know, like, it will it will show you that it's dropping the temperatures, but in reality, it shoots the temperatures to, your tip's gonna glow red hot. So, and that's how you know that your soldering iron is a killing weapon of the motherboard or the graphics card or whatever. So I'm gonna let this thing cool. See, I'll probably clean up the area around it. Obviously, we don't want to leave that there, and then we're gonna go into the testing phase. Because after all, what's the point of doing all this work and not knowing whether or not it worked, if not to actually test it and confirm, so that way we can tell a customer, hey, job's well done, it is tested, it is booting, it is working, pay me. Alright, so we're done with the socket replacement. Now we need to test this thing. Test number 1 is going to require us to test the communications between the memory slots and the PCI Express slot with the CPU. Lucky me, a while ago, I managed to score myself a brand new AM5 CPU. I haven't even opened it yet. Today we will. Today is a special day. So let's go and open this thing. I think I haven't opened it. I'm not sure. I don't think I have. Looks sealed to me, so who cares? Alright, so that's gonna get out of here. And we're going to place that side there. If we can figure out how stupid this lid is designed. There's no handle on the side to grab it on. So thanks a lot, AMD, for designing the sockets the way that you do. So we're gonna drop that in there. Okay, right there. Let's get this out of the way. You're going to need a CPU to test this. Without the CPU, you will not be able to tell whether you did your job correctly or not. So, alright, so the first order of business, I want to see if the memory slot actually makes, that the memory slot data lines actually make their connection all the way to the CPU. So let's plug that in, and I think there will be a couple of signals that will not be going through. I do not know 100%. So let's see. Look over here, press the button, and every single LED is lighting up. So I think on the Intel, not all of them glow. I don't know 100%. So like I said, I don't do this every time, but it looks like on the AM5 socket in here, every single one of them actually getting there, so that's good. We can test the other socket as well. This one's looking good as well. I absolutely despise how they thought that having only one latch on one side was a good idea. It's not. You're always forcing one way. That's not good. So we're good here. That's just a way to save 15 cents. Maybe, I'm not sure. And the last one looks good. Perfect. So we now know that the memory will actually connect with the CPU on all of the data lines. Next in line, we need to test whether the PCI Express slot is also making its way to the CPU. Same thing, there's just a different tester. Plug that in here, and we're going to power. We need to power that thing, obviously. That thing is powered by 12 volt, the regular DC power supply. And once we push the button, we should see all of the LEDs, or none of the LEDs, light up. Let's see if I got a problem with the... Oh, okay. Power supply is off. Never mind. There we go. So, a little bit of wiggle. I'm not too happy with what I'm seeing. I don't know if I'm seeing ghosts or whatever. I'll apply some of the cleaner here. Or maybe a little bit of dirt. Just gonna go in and out. Blow it out. And try again. See if that changes anything. Sometimes, depending on the motherboard, you could have... It could only show like not all the LEDs would light up. Just depends, only half of them. And but in this case, yeah, it looks like we have all of them on this end, all of them on this end, and only few on the other end. Now I don't know. That might actually be normal if the board is using multiplexers. So it's kind of hard to say 100% whether or not everything is working as it should, because I do not know exactly how these AMD CPUs are wired. On the Intel, it would most likely be either all of them or half of them. So, but in this case, I'm gonna have to be a little bit skeptical, though we will put in a X16 graphics card in here for testing purposes. And not to mention, it wouldn't really matter a whole lot if it can't run in x16 and only can run in x8, because oftentimes AMD CPUs themselves that have built-in graphics card, or the adapter rather, they don't even run in x16. So they run in x8 by design. Alright, so let's plug in the memory. Okay, next thing that we need is we're going to need to power this thing on somehow. I think we do have a display on this CPU, so I just want to make sure. I think this CPU does have a built-in display. Let me double check. So it's Ryzen 5 76X, and the chat GPT says it should. Okay, that's cool. Now next thing we need is we're going to need this thingy. This thing will allow me to power the motherboard without the need of bringing in the power supply. So this one's going to go into CPU. I think it's either going to go in here or in there. I think it's going to go here. Not sure which of the ports that we need to power on. Before I do power it on though, I probably want to see if we're having any kind of short circuits anywhere on the board, just to make sure that we're not hit by a surprise of a short circuit of some sort. 20, 1.5, 2, probably the same thing, most likely. Yes, so this looks like all V core. So everything is looking kind of good. 5 volt should be somewhere there, if not here. For the... okay, whatever, who cares? Let's power this thing on. We haven't touched any circuit, though that doesn't necessarily mean that nothing could have gone wrong. Okay, let's put some kind of a cooler here. And probably going to rotate the board so that way we can plug in the HDMI, see if we can get an image going. It might take a while for it to boot for the first time. Who knows? This little adapter here, it's not always reliable. Sometimes it won't even work because of the length of the wires. These things are a little bit picky. I also want to put maybe something on these hubs to keep them cool. Don't know exactly what I can possibly put on here other than this piece of aluminum, something like that, and then maybe I can put... ideally, I would probably want to put something like a small heatsink, such as this here, just for the sake of testing it. And one here, and that should make it happy. The battery, sometimes that's important. The socket on this laptop, on this motherboard, is made in probably worst way possible. It's incredibly difficult to remove the battery. Alright, so we're gonna arm ourselves with a thermal camera so that I can observe what's going on, if there's anything interesting to observe. And let's go and power this thing on. Supply power to the adapter. Make sure nothing is glowing that shouldn't be glowing. I am pulling about 0.3 of an amp, and we have a power button right here. Let's push that power button and see what happens. Alright, so I see all of the V cores lit up. Right now we're just gonna have to wait and see whether or not the thing's gonna boot. I'll probably increase the amperage now that it's stuck at 3 amps and wait and see what happens. It is currently sitting at C7. Complaining about the CPU. So that might be... let's go and power this thing off. That might be related to the little power connector that I plugged into here. It might need to go in here instead. So let's see what that... or it might need both of them. I don't know. So it would be better if we were to plug it correctly with the power supply and everything, with the normal power supply, but I do not want to bring that one out. So, but we could at this point, knowing that there's nothing shorting out and all the voltages seem to be present. So, but let's try again. So we're getting up to 3 amps. The thing says C5, and I'm not sure what that means. It might still be doing its booting thing, so we're just gonna wait to see what happens. Alright, we're gonna try a normal power supply. CPU power does not explicitly state which one's which. Looks like this one's 1, this one's 2. Last time I heard you don't even need these unless you're overclocking, but who knows? Something, I don't know what goes in here. I don't think we need anything here, so let's see what that does. Hopefully we can get past the C5, and it does not look like it's getting past C5 for whatever reason. I don't know. Okay, so the 2 last LEDs are the DRAM and the CPU, so maybe because we had the memory card installed in here, it might need to be installed in here instead. So let's see if that helps. I doubt it, but you never know. Alright, so I think it's actually starting to work. and we might just get a post anytime now, cycling the codes. None of those error LEDs are lit, so let's wait and see what happens. There we go. So the motherboard had finally posted. Let's shut this thing down. It's still cycling the boot. I'm gonna force it shut down. I'm gonna go ahead and see if I can boot, if I can add a graphics card. I'm just gonna add this good old XFX. Should run in X16. I do not know if it's going to actually show up as X16 in the BIOS. Hopefully, and then we're gonna be getting an image from that instead. And we need a PCI Express connector, and we probably want a USB. Probably want a wireless mouse, and let's see if we can go around the BIOS. Maybe some menus over there that will give us the X16 on the graphics. I don't know. Whatever that means. Performance preset. Okay, so I'm not exactly sure. Hardware monitor, performance profile, smart button, favorites. I'm trying to figure out whether or not the GPU is actually X16. I do not know. Nothing is really helping me out. I'm gonna have to install some kind of an NVMe drive here, go into the operating system and see if the graphics card is indeed running as expected, though I'm not exactly sure with this CPU if it's gonna run in X8 by default or it's gonna run in X16. I'm not 100% sure, so we're just gonna have to take this with a grain of salt. So I'm gonna go ahead and do that and see what it does. And I'm running into an issue where I cannot boot from anything. I cannot boot from Windows Boot Manager. I cannot boot from the USB drive. It's got something to do with the BIOS. I'm not exactly sure. Alright, we are in Windows. Apparently some issues with the BIOS that forced me to reflash. So we're probably going to be seeing a lot of gibberish on the GPU-Z. Everything's outdated. Drivers aren't installed, and for whatever reason it does not seem to. Oh, never mind. Yeah, this is actually looking kind of good, except that oh yeah, it's running in 16. There you go. Nice. Okay, so we're good. Gonna go ahead and shut this thing down. I'm not used to seeing stats for this old graphics card. Let me go ahead and see. Now that we know that we actually do run an X16, still makes me wonder why do we not have these two LEDs work. That might actually be normal. So it seems like it's normal for this thing to work like that. It just doesn't make a whole lot of sense the way that this thing is testing on the AMD platform. But there's a lot of things that don't make sense when it comes to the AMD, and I don't really care. And that's it. X16 is working, though I didn't expect it to actually work given the readings that we've seen earlier. Not sure exactly why it was reading it that way. But regardless, seems to be working just fine. So as much as I'm happy to finish this video, I am also a little bit unhappy because it did take a lot of time to get to where we are right now. So definitely will not be looking forward to another socket replacement video anytime soon. Goodbye.